Okay, now we're going to move to some absolute value problems. First off, this one here we just got to evaluate it, which you can put it in your calculator. But I would do this here. First, I would do these absolute values. This means 8 minus 6, which is 2. And 9 minus 20 is negative 11. Now I'm going to go ahead and do the work for the absolute value. This means take the positive value, or means how far away you are from 0, but it just means makes it positive. It's already positive. So I'm going to take 3 times 2, which is 6. But notice I kept it negative 6 in a sense because I'm minusing 6. And now I'm going to come to this one. The absolute value of negative 11 is 11, but I'm going to keep that negative sign in front of it. So I wrote it like that. So that became 11. Now 4 minus 6 is negative 2. Minus 11 makes negative 13. Now you can type that in the calculator also and get your answer. That's probably the easiest way to make sure you do it correctly. Now, forget those negative 6 for a second. But to solve the solution set, this is an equal. You have to get just the absolute value by itself. So I'm going to add 5 to each side first. That cancels out, so I have that. And now then, because absolute value works this way, if you have positive 1 for an answer, it works. If you have negative 1, you make it positive, so negative 1 also works for an answer. So I'm going to solve for two numbers. And as you can see here, that's what the minus 6 was supposed to be. Because in order to solve for the x, I'm going to minus 6 from each side to undo that plus 6. Which gives me that. Because negative 1 minus 6 is negative 7. 1 minus 6 is negative 5. Now I'm going to divide all of them by 3. That cancels out right here. And negative 7 makes it negative 7/3 and negative 5/3. So that's my answer. Negative 7/3, negative 5/3. Now this one is the one with a less than on it. So what I'm going to do is this here. I tend to do this here. I'm looking for values smaller than 7, which means they're going to be in here. So I know that my answer is going to be what I call an in, where the graphs are going to go in. It's kind of making that little note right there. So I wrote the word in. But what I'm going to do is this here, because it's one of these here, I'm just going to go ahead and put a negative 7 there like that. And what that does is it allows me to undo the bars, because I'm looking for values between negative 7 and 7. So I would add 3 to each side, cancels out. So that means that my answer is negative 4 to 10. But because there's no bars underneath here, that means they're open circles on negative 4 and 10, and we graph between it. That's what that particular solution would look like. It would look like that. Now this next one's a little different because it's a greater than. So I'm looking for values that are going out because it's going to be larger than 3 up here. So the other one's going to be going out. They're going to go out. These are what I call outies. So I'm going to rewrite this problem. Basically, I'm looking for values that are smaller than negative 3 for it to work and larger than 3. So I kind of like to do it as an equal like this here. I just know that they're going to go out. That's how I do it. I set these up as equals and know that they're going out because I'm looking for values that are larger. So I'm minus 5 from each side. That means negative 3 minus 5 is negative 8. 3 minus 5 is negative 2. And my graph's not really very good there because I had to kind of extend my line because negative 8 wasn't quite on it. So I added some lines here, negative 8, 2. And notice the graphs are going out. And they go to infinity and beyond each of those directions. All right? There is no number 20, so pay no attention to that man behind the curtain. Okay. 21 is this here. Suppose you got a thermometer. Is accurate within plus or minus 76.5 degrees. I think there's a 0.3 missing there that you can't see. 0.3 right here. Okay. So basically we take the temperature. If we minus 76.5, if it's smaller than 76.5, it'll be a negative, but the absolute value of that will still be less than 0.3. And if it's a little larger than 76.5 and you minus it, it'll be positive. So that's how you write this answer. You're looking for an equation that will have this for an answer. There will be absolute value with the variable here minus less than or equal to whatever your variance is supposed to be.